All right, so here we go with the next acid-base theory. This is the Bronsted-Lowry Theories, and this came about in 1923, so a little bit after the Arrhenius definition. So the Arrhenius definition of acids and bases, it only works when an H plus or an OH minus is produced. So that puts some limitations on things because that doesn't always happen. So to broaden the definition of acids and bases, Bronsted and Lowry independently came up with this definition of acids and bases. One other thing that's important about this chapter is it's important to note that unlike atomic theory, the acid and base theories, they work together. There isn't one correct theory because they're all correct. They just each define different types of acids and bases. So as we go through, we'll find that each theory more broadly defines acids and bases. So for example, Arrhenius, the only things that you could define as an acid or a base had to look like these two things. So it's an H in the beginning. Okay, so that's an acid. And then an OH at the end, that's a base because when this is put in water, it's going to produce OH minus, and then when this is put in water, it's going to produce H plus. Now that's great, but there are some other things like ammonia, which is NH3, that if you were to have this go through a reaction, this would actually act like a base, but you don't see OH in there. And so for Arrhenius, he wouldn't be able to define this as a base, even though it is a base. So the next one, the Bronsted-Lowry definition, that'll actually allow us to define more things as acids and bases. All right, so let's get rolling. A Bronsted-Lowry acid is a molecule or an ion that is a proton donor. All right, so Arrhenius said that it needs to produce an H plus. Bronsted-Lowry says it doesn't need to produce an H plus, it just needs to donate a proton. And you guys know that a proton is the same thing as an H plus, because if we take an atom of hydrogen that's got a nucleus, all right, with its one little positive proton in there, and then around it you have a negative electron floating around, right? If you take that electron away, all that's left is the center part, which is positive, and that's why H plus is referred to as a proton. All right, so they're going to be like interchangeable. So if you donate an H plus, or if you are a proton donor, you're going to be a Bronsted-Lowry acid. And if we go back to HCl, we said this was an Arrhenius acid, right? It's an Arrhenius acid because it produces H plus, because when you put it into water, it's going to break off into H plus and then Cl minus. And it's also donating that H plus to something else. So it's both an Arrhenius acid and a Bronsted-Lowry acid. They work together. All right, it's very similar. But it allows us to broaden the definition for some things. And I'll show you some examples as we move on. All right, so that's kind of the definition for a Bronsted-Lowry acid. And then a Bronsted-Lowry base is a molecule or ion that is a proton acceptor. So it's something that takes in H pluses. Now let's talk about the other example, NaOH. This was an Arrhenius base, right? Because when you put this in water, it'll break apart into Na plus and OH minus, right? It produced OH minus. Now, why is this a proton acceptor? Well, if you think about it, if it's in water, there's going to be maybe some H pluses in the water, and they're going to be attracted to each other. And this OH is going to accept this H plus and then become HOH, which is H2O. All right. So this is an OH. All right. Again, it produced an OH, so it's going to be an Arrhenius base, but it's also a Bronsted-Lowry base because that OH is going to pick up an H plus in the water, because there's a bunch of H pluses in the water. There's a bunch of OH minuses in there just floating around. So it's going to pick one of those up, it's going to form water. And so because it accepted H+, it's a Bronsted-Lowry base. Okay, so it's probably a little bit confusing, but once we get into actual examples, it makes it a lot easier, all right? The Bronsted-Lowry acid-base reaction. So overall, in a Bronsted-Lowry reaction, protons are transferred from one reactant, which is the acid, because again, it's going to be a proton donor, to another, which is the base, because that's going to be the proton acceptor. The key for us is to be able to figure out which is losing and which is gaining that proton. And that's the trick here, and that's what we're going to go over next.